Hello, and welcome to this presentation, Getting Started with the CMA180 Zero Span. In this presentation, we'll explain how to configure and use the zero span function of the Rohde Schwarz CMA180 radio test set. This presentation assumes a basic understanding of zero span, as well as a basic knowledge of how to configure and use spectrum analyzer mode on the CMA180. If you're unfamiliar with these topics, or if you'd like a brief review, you might want to watch the presentations Understanding Zero Span and/or Getting Started with the CMA180 Spectrum Analyzer before beginning this presentation. The CMA180 Spectrum Analyzer option K120 enables two different spectrum analysis modes. The first of these is Frequency Sweep mode, in which the CMA measures and displays power as a function of frequency. Frequency Sweep mode is covered in a separate presentation. The second is Zero Span mode, in which measured power is shown as a function of time. Zero Span mode is primarily used for measuring time-varying signals, for example signals from radios that use bursted or slotted transmission schemes. To select the spectrum analyzer scenario, click on the global toolbar and then choose Spectrum under the Analog tab. Once the application is started, press the folder icon to toggle between Split mode, which shows the generator and analyzer applications side by side, and the Merged mode, where only one application is displayed at a time. The device under test can be connected to either the RF COM or the RF in connectors on the front of the CMA. This is selected in the RF Settings tab under Spectrum Configuration. Note that these two connectors have different maximum input power levels, 100 watts continuous and up to 150 watts maximum on RF COM, but only plus 20 dBm or 100 milliwatts on RF in. An external attenuation value, either from an attenuator or due to cable loss, can also be specified. Note that this RF connection is the only one required for zero span measurements, although other types of connections can also be made. For example, an audio connection to supply an AF signal to the DUT audio input. Let's look at the main zero span screen. Note that zero span is accessed via a tab along the bottom edge of the display. The buttons on the right side are used to start, stop, and pause the measurements. At the top of the screen are the most important measurement parameters. In the center is the power versus time display, and at the bottom is the table of marker values. In the remainder of this presentation, we'll go through each of these areas and explain how they're used in performing zero span measurements on the CMA180. The most important parameters for zero span analysis are shown and configured at the top of the main screen. The center frequency of the signal is chosen using frequency. Note that unlike frequency sweep measurements, this value is not shown on the result display. Sweep time is used to specify the width of the time axis, that is, the duration of the zero span measurement. The expected power should be configured slightly higher than the maximum expected input signal power. This is the same as reference level in most spectrum analyzers. And finally, the RBW or resolution bandwidth setting is the width of the filter used to measure power in zero span mode. This should be set slightly wider than the bandwidth of the measured signal. Please see the separate presentation, Understanding Zero Span, if you'd like a more detailed explanation of these parameters. As you should already know, zero span measurements usually require some type of trigger. This is the condition or event which starts a single measurement sweep, and is configured by clicking on the trigger icon. The trigger source can be a change in the signal level itself, an external signal, the output of the CMA's generator, etc. Although it's possible to operate in free-run mode with no trigger, the most common scenario is using a so-called video trigger, which is simply the signal level crossing a defined threshold in a given direction. In the example shown, the CMA will start the measurement when the signal level rises through the minus 40 dB level. Additional trigger parameters include offset, which shifts the trigger point on the display, as well as more advanced features such as a trigger timeout or a gap. Please see the CMA documentation for an explanation of these less common trigger parameters. The waveform is displayed after the trigger occurs, and by default the CMA scales the X or time axis and the Y or power axis automatically. These can, however, be manually scaled directly from the main display by clicking on the icon shown. Note too that the CMA also supports zooming in on an area of the display using the standard click and drag technique to draw a box around the area of interest. In addition to the basic parameters, additional zero-span settings are available by clicking the configuration icon in the bottom right corner of the screen and then choosing Analyzer Settings. The zero-span settings are found in the bottom portion of this dialog. The configuration icon in the results area can also be used to specify various parameters, in particular the filter type, which is set to Gaussian by default. Note that throughout the CMA, a green check mark next to a value indicates that it was automatically set. Markers can be used to obtain precise numerical values from the trace. These are enabled by clicking on the marker icon on the right side of the display area. There are three types of markers: reference markers, as well as markers showing absolute values and values relative to this marker. Markers can be placed manually by entering a numeric value, and they can also be placed and adjusted by clicking and dragging on the display. There are also marker search functions, which can be used to automatically find peaks, etc. Marker search functions are described in more detail in the frequency sweep mode presentation. Numerical values for configured markers are shown in the table along the bottom of the screen. Here's a quick example of using markers in zero-span mode. A reference marker was placed at the start of the burst, and a delta marker was then placed at the end of the burst. The numerical results showed that this initial burst was almost exactly 60 milliseconds long, and that the amplitude at the end of the burst was approximately 0.6 dB higher than the amplitude at the start of the burst. Let's end with a brief summary. The Rohde Schwarz CMA180 radio test set can perform both swept frequency and zero-span measurements when equipped with the K120 license option. In this presentation, we focused on zero-span mode, with frequency sweep mode being the topic of a separate presentation. The device under test can be connected to either of the CMA's two RF input ports, although be sure to observe the maximum input power for each port. Zero-span measurement parameters such as center, sweep time, RBW, etc. are all user configurable. Recall that zero-span measurements usually require a properly configured trigger to obtain useful and stable measurements. Measurement results are shown as a trace of power versus time. The CMA's marker functions can be used to obtain precise numeric values from a trace, and these markers can be placed manually or automatically, both as absolute or as relative markers. This concludes our presentation, Getting Started with the CMA180 Zero-Span. If you'd like to learn more about spectrum analysis, the CMA180, or other CMA180 measurements, please see the links in the video description. Thanks for watching. Please subscribe to our YouTube channel and visit us at rohde-schwarz.com.